All right. Good afternoon, everyone. Today we are going to be going over the basic hierarchy of bodies and collections of bodies in the universe, right? So, celestial bodies, everything in the universe really is a celestial body in some way or another. That phrase or that phrase can be more specific or less specific depending on the context, but today we're going to be talking about what the organization of these bodies is and what it's called. And in the next couple weeks, we'll be going over specific examples of the celestial bodies, as well as going over our solar system because that's part of this organizational structure, right? But for today, I think we're going to start with defining what a solar system is, right? So a solar system is a star or stars, and the object or objects, which is what the parentheses S means. So, and the object or objects that orbit it or orbit them, right? So, why I say star or stars is because there are quite a few in the universe. Dual star systems where you have two stars that orbit each other, and they also will have orbiting bodies that orbit both of them in their little tandem dance, right? So the solar system is not always restricted to just being a one star system. Sometimes a solar system is a two-star system, and these two stars will dance and have bodies orbiting the two of them while they orbit each other, right? Now, it's important to know that this is what a solar system is because, as you can see, the solar system is the bottom of our celestial body organization, right? So the celestial bodies are organized in solar systems, which are made up of a star or stars. And then the star has planets or a planet that orbit the star. Then you have planetoids, which are large objects that do not quite classify as a planet. Think Pluto and I think Sharon or Karen, or I'm not really 100% sure how to say the sister to Pluto, but planetoid objects that are very massive, too large usually to be classified as an asteroid or comet, but aren't quite massive enough to classify as a planet, right? So we call those planetoids. Then you have asteroids, and asteroids just more. I should add the slash here of comets, right? So asteroids and comets, you're going to have these super small pieces of debris, basically. That's all these are. And when I say super small, I'm talking in terms of the universe, okay? Like, yes, stars and planets are super small in terms of the universe, but nowhere near on the scale that, like, asteroids and comets are. Asteroids and comets can be the size of literal, continents on the United States. Or continents in, like, the United States is North America and South America. It could be the size of all of Eurasia, right? And that object is actually considered small because it's not massive enough to be considered like a planetoid or a planet, right? So these objects are small in relative terms. And they're basically leftover pieces, right? Then you have planetoids, which are usually failed rocky planets. So these were during the process that the solar system is formed, which we'll go over a little bit more detail in another episode. The process that the solar system is formed called accretion. The planetoids may have perhaps gotten too close to the sun at some point, and resulting in kind of a whiplash effect, which we use to often get satellites out further in the solar system than what our fuel can possibly get it. So we use this slingshot. That's what it is. Slingshot effect, right? Where we sling the planet, or use the planet's gravity, or in this case, the sun's gravity, to sling the object into deeper space, right? And we've done this for numerous expeditions and numerous sending of satellites and other investigative equipment deeper into our solar system. And in fact, we have an object now that has passed the Kuiper Belt, which we'll go over in another episode. Another object has passed the Kuiper Belt, and the Voyager 2 has now passed the Kuiper Belt and is now on its way to the Oort cloud. But that will take Lord knows how many years for it to reach even the inner edge of the Kuiper, or the Oort cloud, and for it to then pass through the outer edge of the Oort cloud will take another few years. So, but some of these planetoids, maybe during the forming of the solar system, were flung out of the inner solar system, where the rocky, more dense material may have formed the rocky planets, right? And they were flung out before they finished their accretion into a larger object, right? But irrelevant. And then behind, irrelevant for today's discussion, I should say. In following discussions, we'll talk more on the formation of our solar system, as well as what we understand to be the formation of solar systems in general. And we'll discuss how these planetoids, asteroids, and such like that came into existence, right? But and underneath planets also have their own system known as, planetary systems that we call the orbiting bodies of planets satellites. And many people get misconstrued with satellites and think that satellites are just man-made objects that we launched into geosynchronous orbit with the Earth in order to, like, study our weather, or low Earth orbit to perhaps launch communication satellites, things like that, right? So satellites are also known as moons when they're natural bodies, and there is more that classifies a moon specifically over a satellite. But overall, anything that orbits a planet, anything that orbits another object in general, is technically a satellite of that object. But satellite is just a blanket term for anything that orbits a planet, usually, right? So this is the basic structure of a solar system. And then the solar system is just one super tiny piece. And yes, I understand, once again, that the solar system is not small. But when you look at the grand scheme of things, the solar system is incredibly small, right? And so you got the solar system makes up a much larger collection of objects and other solar systems and planets and such, known as a galaxy or galaxies, right? Now, the galaxy is usually going to be, depending on how old the galaxy is and how strong the gravitational effect of the galaxy is, many galaxies are shaped like a disk. Like, imagine a frisbee thrown through space that's just got a little bulge right in the middle, where it's hypothesized that supermassive black holes reside at the center of spiral galaxies, right? And you just have a disk that's flying through space, like someone just threw a frisbee through space. That's basically what many galaxies are. Although spiral galaxies are not the exclusive form of galaxies in the universe. There are other forms of galaxies that, once again, we will get into in later episodes. But this is just to kind of go over the basic structure of the universe and kind of the hierarchy of how organization is, right? And so you have solar systems which will usually, but not always, be inside of a galaxy. And there are some times that the stars will, for whatever reason, once again, maybe being slung out of their galaxy, maybe when two galaxies collide, like the Milky Way and the Andromeda Galaxy are proposed to be doing in the next few billion years, right? When galaxies collide, or maybe when that solar system was too close to the middle of the galaxy and maybe got flung out by a slingshot effect from the supermassive black hole in the middle, right? No matter what, there are some solar systems that do not exist in galaxies, right? But most solar systems you're going to find are inside of galaxies. And most galaxies that you are going to find exist inside of clusters. And clusters are just as it sounds, it's just a huge cluster of galaxies. It's a bunch of galaxies that are all relatively close together, that are held as relatively close together as they are by their own gravity. So the galaxy gravity holds them together in structures known as clusters, and then these clusters can coalesce into larger clusters that we then call superclusters. But these superclusters are then leaving massive amounts of space in between these clusters and superclusters and such like that. And these spaces that the universe has between the superclusters and the clusters are called voids, right? And voids, just as the name implies, are just massive spaces that are either super low in stars or don't have stars at all. And definitely won't have like galaxies or clusters or anything like that. And that's the clusters and the superclusters being absent from a void is what makes it a void. And then galaxies and solar systems can exist in a void, but they're very few and far between. That's, once again, kind of why it's called a void. But you have to understand that a void doesn't mean it's completely empty. It's just got so little in it that without extremely high magnification on super small pinpoint areas of space, you're never going to see a star in that void. Like the largest void that we have observed is called the Boots Void, I think it's called. And that void is so massive that it has confused many in the scientific community as to how such a massive space is completely empty, or relatively empty, of matter and of stars and galaxies and clusters, right? Why is so much space empty? Just as we try to understand why space organizes itself the way that it does, we also try to understand why space has so much space in certain places, right? Because we are going based off of our understanding of like diffusion and how things like to be at equilibrium, but everything we observe, equilibrium is never really attained. So going back to this though, to finish up and summarize this episode, you have asteroids, comets, planetoids, and planets all make up a solar system that surround a star or stars. The planets can have their own system with satellites and moons, but all of this fits in an orbit around a star, and then or stars, and then this solar system orbits a supermassive black hole in a spiral galaxy, and usually they just coalesce around a very massive gravitational field. Most of the time though, it's around a supermassive black hole. But some galaxies, I'm sure they found some galaxies don't necessarily abide by that principle, but very rare. Usually it'll be around a supermassive black hole. These solar systems will form galaxies. And then these galaxies, their gravity will be so intense because of the amount of mass and all the stars and solar systems that they have, as well as their supermassive black hole, they will form into clusters, which then their gravity becomes so massive that they form into superclusters. And these superclusters create voids because the superclusters attract everything in, and if it's not within a certain distance, the supercluster will not attract it anymore, right? Because as we know, gravity, even though it's not actually a force, is relatively weak when you compare it to other forces, right? But that is the basic breakdown of solar systems and the universe and the hierarchy between them. And that will conclude today's episode on Shinrai Sensei, going into science, and hopefully we've learned something, and hopefully we're getting better together.